Good afternoon, everyone. Today, we'll explore how to build large language models for low-resource language with SageMaker HyperPod cluster. So this is Jackie Chan from Hong Kong. In order to kickstart, we'll go through a very quick self-introduction, and then we'll go through the challenges of training large language models for low-resource languages. And then we'll also cover how we prepare the data, and then up to like doing the training, evaluation, and then to the real-world applications. Okay, so let me very quickly introduce myself. I'm Jackie Chan from Hong Kong. I'm also the AWS community builder for machine learning and generative AI. And I'm CTO of Voti AI as well. I have been giving talks in AWS events in Hong Kong and China for over years. And today is my honor to speak here, as this is the first time I come to reInvent. Okay, so to start with, so not all languages are equal. What does it mean? So currently, there are over 6,000, some say over 7,000 human languages in the world, and each with its own unique characteristics shaped by social, cultural, political, and economic influences. However, there is a study from Australia published at the Nature Journal in 2022, which is the figure on the right. And it shows that in the next 100 years, over 1,500 languages could be lost. Or in a more pessimistic view, 90% would go extinct. So we see safeguarding human languages as the carrier of intangible cultural heritage, very important in the near future. And especially with the help of the current generative AI technologies, it could be large language model or even large multimodal model, which can be served as the container of languages in order to preserve the cultures, knowledge, and also the mindsets. Looking at the multilingual statistics from Wikipedia, as you can see, English and Chinese are considered as high-resource languages. And it has abundance of available data and resources. However, you can see Cantonese is considered as a low-resource language. Here, it ranked 83. Which means the languages have limited linguistic resources available for computational processing and analysis. You can also see that the numbers of articles for Chinese is over 20 times than Cantonese, right? And not to mention for English, it is another 10 times of Chinese. And so you can see that most of the languages in the world are actually low-resource languages. And that actually hinders the development of the large language model for local languages. Despite being a low-resource language, Cantonese is one of the most spoken languages in the world, with over 86 million speakers and ranked top 20. It is widely used in Hong Kong, Macau, Guangdong Province, Southeast Asia, and overseas Chinatowns. This is an edge for us to break through the challenges to build large language models for low-resource languages. When we prepared the training data, we actually face several challenges. And even official data may always have the quality issues. So we have been gathering various types of tests, such as vocabularies from dictionaries, or tests from surveys, or reviews, news, and textbooks, and also conversations through subtitles. We utilize different data sources like surveys, social listening, web crawling, and public data sets, And the key part for handling the low resource languages would be about the data processing. So we need to go through all the data cleaning, data deduplication, de-identification, and also we need to keep track of the quality control to make sure the data set is accurate and representative. So here is another example, which is the official data set from Wikimedia at Hugging Face. You can see for the Cantonese test, they have brackets and punctuations in between, but it doesn't have any contents. So the contents are actually missing because they are actually from the rich metadata, which could be about pronunciations, about geolocations, or other background information. And so when for traditional large language models trained using these data sets, they will have some information missed and even hallucinate. And so we fix that by making sure all the data are extracted properly and make in place. Here is an example of Hong Kong. So you can see with all the background information within the table, which is extracted properly, and we have all the numbers, and also we have the pronunciation Yu Ping, which is the Cantonese romanization for pronunciation, and also the English name all in place. And we also have learned how to extract data for low resource languages properly. You can see that from the high level point of view, we have different flowcharts to help create the data sets for low resource languages, which is basically all our synthetic data operations. For example, we have the translation on existing data sets. We also based on persona to generate different data sets. And also we collect colloquial how to express the local languages. The magic here is that all these operations are done through a data pipeline generation using advanced agentic large language model. So after all the data is prepared, we can set up the training environment on AWS using the cloud formation. You can scan the QR code here on the top right corner. And so it will help you to set up everything from the cluster admin to the lifecycle script. And then for yourself, you also need to prepare some resources, for example, setting up the S3 buckets, and also the VPC subnets. Here is the FX6 for Lustre, which is a high-performance file system specifically for handling tasks such as training large language models. So once you have run the script, the cluster is created. You can go through the SSH and then get into the cluster. And you can run jobs just like other cluster using the Slump environment. And you can use srun or sbash to manage your training jobs. And here you can see that we have different compute nodes, and when we were doing the training, we are still using the ML Trainium 1 32x large model, which has 16 Trainium accelerators with 32 neuron cores. So as you know, in this reInvent, the CEO has also announced about the general availability of Trainium 2, which will just be more powerful. And this architecture guarantees the whole cluster setup has the performance better than other GPU cluster has. And then here, you can also scan the QR code, which can allow you to have the access to the complete script to train. Here is the example of Meta's Llama 3.1 8B, with also the tensor parallelism, and also the zero redundancy optimizer, stage 1 optimizer. So these are all based on the Neuron X distributed from the Amazon Neuron SDK. And in our training, this is basically automated using this script. And with the data, the cluster, and the Llama training script all in place, we are ready to start the training of our large language model. And here is the interface displaying the real-time logs of training the epochs, the parameter updates, and also the validation loss, alongside with the neuron core utilization metrics. You can see that this training took around 300 hours, more than 300 hours, or nearly 2 weeks to complete. The architecture is actually scalable to deploy with more accelerator nodes. For this one, I'm using just one accelerator node, but we can use more. And so that the training time can be shortened to maybe in days or hours. Okay, so let's take a look at what we have trained. Our evaluation shows promising results. Using perplexity as a metric, our Cantonese large language model achieves the lowest score. So the lower, the better. Our research community is also working on an academic paper with a more sophisticated benchmarking, just like MMLU, to demonstrate that we are having a state-of-the-art model. And here comes a very simple example of showing the actual chatbot usage in the mix of Cantonese and English, which is very common in Hong Kong. We asked about the culture of Chatanting, the Hong Kong-style restaurant, and we also continue to ask how to eat more healthily given the Chinese food is usually very oily. As the test is purely in Chinese, and so we also manually do the English translation for you guys to do the understanding. So you can see that the model can actually understand Cantonese well and answer also properly. Here is another example, which is writing on our social listening platform, and we gather social media posts and comments from major social media platforms. The contents of the test are usually less formal and may contain internet terms, jargons, slangs, and we use our models to help read through the posts and summarize into key highlights and with fine-grained sentiment analysis. This opens up different scenarios that need local language understanding among different industries. With the experience of building Cantonese large language model, we want to share with you all how to build and help other low-resource languages and help the industries to adopt. We do actually open source, open data, and also open waste, which means opening the models. We upload everything, we release everything on Hugging Face. And so if you are interested to build large language model for your own local languages, please feel free to contact me. And here is the QR code to access the Cantonese large language model on Hugging Face. And here is my contact, and I will be available to take questions outside the theater. Thank you very much.